Yeah, so this is the broad classification of additive manufacturing process as per ASTM, American Standard for Testing of Materials, F2792, and additive manufacturing process classification. So most of the processes are there in your syllabus. Okay, so if you see the binder jetting, so this is there in your first unit. So binder jetting means there is a powder material will be there in the bin, or a layer will be deposited on the platform, and there we deposit the binders in the form of a droplets, so that we call as binder jetting process. Otherwise, what I will do, okay, so let us complete this and then I will go to another PPT. Okay, and next one is material extrusion, so that is there in our syllabus. Direct energy deposition not there, but I will explain later on. Material extrusion means FDM process. FDM process. Okay, and material jetting. So in the material jetting means here we will deposit a fine droplets of molten material, onto the platform, and with the help of laser beams, and that will be sintered and solidified. And the next one is the powder bed fusion. So powder bed fusion means selective laser sintering. Selective laser sintering. That means a powder will be there on the bed, or on the platform, and with the help of laser beam, that a powder will be melted and solidified and bonded together. And the sheet lamination means laminated object manufacturing. Laminated object manufacturing. Here we take the raw material in the form of a sheet and we cut into a desired shape layer by layer, and in between the layers there will be adhesive material will be there to bond the between the two layers. And here photopolymerization means not selective, stereolithography. Stereolithography. Here, photo polymerization means a liquid material will be there in the bin. A liquid material will be there in the bin, and that will be solidified by exposing to a laser beam. Okay. Earlier, people used to call as this one as stereolithography, but now it is renamed as per ASTM as VAT photopolymerization. VAT means a bin in which the liquid material will be there, along with the piston or a platform. And as the platform lowers down, the layer by layer building will take place in the stereolithography or VAT photopolymerization. So that is about in glance about your syllabus. Okay, I will open one more PPT so there you can see some more things. So this is a consolidated sheet of all the manufacturing processes. Yeah. So whatever the thing which we have discussed, so this is in a consolidated. Okay, in a single slide, all these 7 processes. Actually, the additive manufacturing process or a 3D printing process is classified into seven processes. 7 processes. So that's why it is more standard one, because it is given by ASTM. Okay, so that's what you can see the first one. Okay, actually the additive manufacturing process is classified into 3 categories: liquid based, solid based, and powder based. So the first one you can see here, VAT photopolymerization. So here we use a liquid material, you can see here, and the layer by layer solidification takes place by lowering the platform, but whichever the layer which is exposed to the laser beam, and that will be solidified. So the other names for this, the VAT photopolymer are, okay, other names with the small modification in the process. The first one you can see here, stereolithography apparatus. And this machine we can also call as a digital light processing, or 3SP: scan, spin, selectively photocure, and clip, that is continuous liquid interface production. Okay, so here mostly we use resins in this. That means it is made with the resins. but the resins should have a property of UV curable photopolymers. That means we use a polymers resins, and those polymer resins should have a capability to curable, that is certification property under UV light exposing. And the next process you can see here, powder bed fusion. So under the powder bed fusions, in our syllabus, we are having selective laser sintering. Selective laser sintering, the first process, but with a small modification with this process, other processes are developed, that is direct metal laser sintering or selective laser melting, electron beam melting, selective heat sintering, multi-jet fusion. Okay, whatever the maybe the process, but the only thing is the input material, the raw material is in the form of a powder, but how we are going to heat, melt and solidify, heat, melt and solidify, we go with the different methods. We go with the different methods. If you use electron beams, then it is called as electron beam melting. Okay, and if you use a laser beam, if you use a laser beam, then people may call as a selective laser melting, selective laser melting. And if you are using a multi lasers or a multi electron beams at different locations, then we call as multi jet fusion, multi jet fusion. And here the typical material we use are plastics, metals, ceramic powders, and sand also we use it. So that is about powder bed fusion process. And the next one is a binder jet process. So that's what just now we discussed. In a binder jet processing, we use a powder only here. Okay, but that powder is bonded together by depositing the binding material. That is bonding agents. You can see here. Let me take pen. You can see here. Okay, liquid bonding agents are selectively applied onto the thin layers of the powder to bond up parts layer by layer. Okay, so here what type of powder, against the whatever the powder which we are using in the powder bed fusion, the same powder we are using here, we can use it and we can manufacture the components. And the next one is a material jetting. That's what I told in the previous slide with the classification. Okay, as per the earlier state. So here we deposit a material, but along with the material, the laser beam or UV light beam, we use it to solidify it, cure it, and solidify it. That is, the droplets of the material are deposited by layer. And the common varieties which include the jetting of photocurable resins, curing it with a UV light, as well as jetting thermally molten material that then solidified with the ambient temperature. Ambient temperature. So this is a material jetting process. And here also we use the plastics and the wax only, as similar to wet photopolymerization. And you can see here another solid based 3D printing process is a sheet lamination, and in our syllabus it is named with LOM, that is laminated object manufacturing. You can see here laminated object manufacturing or selective deposition lamination, ultrasonic additive manufacturing, ultrasonic additive manufacturing. So these are the different processes we use it under, or different process names for sheet lamination. Here we take the input material, that is we take the plastic materials, metal foils or tapes, and the paper also we use it. And the most commonly used process is material extrusion. Material extrusion. So this also comes under solid based manufacturing, solid based 3D printing. LOM is also solid based 3D printing process. But here the raw material we take it in the form of a Y, and that is melted with the external heat, especially electrical heat, and the plastic material will be melted, and the molten material will be deposited onto the platform layer by layer. And then here also we use mostly plastics, but the main advantage of this process is very cheaply available material, low cost process. Okay, so these are there in our syllabus, but you can see here there is another process we named it earlier, that is the direct energy deposition. Direct energy deposition, and this process is also called as a laser metal deposition, as well as we can also call it as a laser engineered net shaping process, or direct metal deposition, DMD. Direct metal deposition process also we call. But what is the, okay, this process we will not discuss, I will discuss a little bit more. So here you can see this is a nozzle. Okay, this nozzle is having a 2 points. One point is, this is in a, let us assume, if you assume as a hopper, in the hopper we place the raw material in the form of a powder, raw material in the form of a powder or wire, and that is deposited. Okay, that is the draw. Okay, the powder will be deposited okay, in a okay, in a systematic pattern. That means the powder will be ejected or will come out from the nozzle in a systematic form. But when it is coming out, we, okay, with the help of some external source, we generate heat source by, that may be a laser or electron beam, maybe a laser or electron beam. That means we want, okay, suppose if you see, this is a top view, there will be a three holes or a three orifices will be there. In the center orifice we use for generating a heat source either with the laser beam or electronic beam, but the other two holes are the nozzles, we use it for depositing or sending the raw material in the form of a powder towards the laser beam or electronic beam. So the laser beam and electronic beam will interact with this powder, and as the laser beam and the electronic beam will have a high temperature, and due to the temperature, the metal will be the powder material will be converted into, the powdered material will be converted into liquid material, and that liquid material will be deposited onto the platform layer by layer, layer by layer. So the layer by layer will be built, and finally you are going to produce a product. Okay, the main strength of this process is not limited by a direction and axis, so there is no limit to the axis and direction, and effective for the repairs and adding the features. That means mostly this process we use it for repairing of any component which is damaged, or suppose if you use a process continuously, that part has worn out. Let us assume that part has worn out. The worn out part, if you want to get it back to its original dimensions, so we deposit using this method. We call as direct energy deposition method. And multi-materials can be used for the single part. That's what you can see here. Suppose if this chamber is divided into two chambers, and in one chamber you can place it one material, another chamber you can place another material, and when these two comes here, and those will be melted and it will be deposited over here, and then deposited material, and the deposited material can be solidified into required a different material, and the different material will be have a different properties. And highest single point deposition rate, that means the production rate is very high. And the typical material we use, all the material powders, or whichever the material, or the material form, the material which are available in the powder form can be used in this process along with ceramics, along with the ceramics. And now the last process you can see here, hybrid manufacturing process. What do you mean by hybrid manufacturing process? Can anybody guess? Can anybody guess hybrid manufacturing process? Yes. Can anybody guess hybrid manufacturing process? Yes.
Sir, in the like a combination of two processes, two or more processes,
Combination of,
two or more processes.
exactly right. Exactly right. Here, the hybrid manufacturing process not only producing the layer by layer manufacturing. At the same time, that manufacturing process is having a facility to finishing on the same machine. On the same machine. That's what you can see here. The layer deposition. Okay, layer metal deposition is combined with the CNC machining process, which allows the additive manufacturing and the subtractive manufacturing to be performed in a single machine so that the parts can be utilized. The strength of the both the process, strength of the both the process, it can be utilized. That means the laser metal deposition. That means the hybrid manufacturing process consisting of both additive manufacturing as well as machining process. That means remove metal removal process. Okay, additive manufacturing is addition process, and subtractive manufacturing also will be there along with that, so that one side we are depositing and manufacturing, and another side we are removing unwanted material, so that we'll get the desired surface finish. We'll get the desired surface finish. So that's what you can see here. Okay, so this is a layer droplets it is depositing, but other backside there are two more tool holders are there, and here you can assume this is a drilling process, and this you can assume as a milling process and the drilling process, and here additive manufacturing process. So combinedly we call as manufacturing process hybrid manufacturing process. So these are the 7 plus 1 okay, are the families of additive manufacturing as per ASTM F2792 standards. Okay, so that is about that.